Hello all, myself Manikanta, and I'm currently pursuing my BTech degree in Electrical and Electronic Domain in JNTUA College of Engineering, Kalikiri.
Hello, I'm P. Clarpa from EC department. I'm currently pursuing my BTech first third year in EC department in JNTUA College of Kalikiri.
Hello everyone. Myself, Y. Saiharan Kumar Reddy, currently pursuing BTech EC in JNTUA College of Engineering, Kalikiri. Now my friend Manikanta will continue the presentation.
C programming. C programming consists of different topics as shown here. The data types and modifiers are the main main considerations for defining the data. The conditional and looping statements are used for decreasing the code and providing us efficiency to for looping statements. Examples like for and while loops. Operators are the main uh, main operators like arithmetic, boolean, bitwise, etc. The arrays and pointers are used for memory locations, and functions are the defined are used for defined tasks, and preprocessor directories are like header files, etc. It is the basic structure of the C. Documentation is providing the main elements or main matter which is not included in the code, like the programmer date, etc. Next, it consists of preprocessor directories like stdio.h, which is a preprocessor directory, and global declaration, and it consists of main function and a user defined function. The user defined functions are generally defined by the user as per the requirement. There is a vast difference between C programming and embedded C. The embedded C is used in these embedded systems for designing our project. The main differences are scope. I mean, the embedded C is only specialized for embedded systems, but it's C is general programming language. The general development tools are used in C programming, but IDEs are used in embedded C. The debugging is used for specific microcontroller tools in embedded C, but standard debugging is used in C programming. And the challenges are very less in C programming, but there are vast challenges and real-time demands in embedded C. My friend will continue the next slide.
The software tools we are using in this project is MPLAB XIDE for programming purpose and MPLAB XC8 microcontroller compiler, which is used for the compilation of the code which we have written in MPLAB XIDE. The hex file which we dump in the PiximLab, which is a simulating tool. In PiximLab, we dump the code in the form of hex file so that the reason it executes our functionality. The microcontroller we are using in our project is PiximLab 16F877A microcontroller board, which for this microcontroller we can interface a lot of peripherals like GPIOs, real-time clocks, memories, temperature sensors, analog to digital converters, LEDs, buzzers, digital keypads, matrix keypads, CLCDs, like this. Many kind of peripherals we can be interface to this microcontroller. The microcontroller PIC 16F877A mainly has 4 to 5 ports, like as shown in the figure. It can be used for the different peripherals like timers, controller, counters, pulse width modulators, and many communication protocols can be also interfaced like SPA, I2C, EVC, RT. It mainly consists of 33 input-output ports. The features of this PIC 16F877A is it is a 8-bit RISC CPU. It operates for the 20 MHz frequency operation. Its operating voltage is 4 volts to 5.5 volts. It is mainly consists of watchdog timer, core protection, power saving sleep mode. So the reason we have selected this microcontroller board for our project. My friend Kulayappa will continue this presentation.
Interrupts. Whereas interrupts are the signals which alter the flow of an execution program by causing the microcontroller jumps into the interrupt service routine to serve to the interrupter. Interrupt source. Whereas interrupts are classified into two types: hardware, software, and again hardware are classified into non-maskable and maskable. Maskable again divided into external and internal. Interrupt source. An internal or external devices requires the microprocessor unit to stop processing. The microprocessor unit acknowledges the request, attend to the request, go back to the external where it has interrupted. Here the program or execution goes to the address of the interrupt and solve the interrupt, and then execute takes place. Whereas timers, they are used to keep a record of time for different events occurring in the embedded system. In PIC 16 F87AA, there are three timer modules. Time 0, 8-bit, it consists 8-bit timer, and another one is timer 1 and timer 2. The timer module is an 8-bit timer count with following features: 8-bit timer, readable and writable. Mainly in this micro project, we can use timer 2 module. Timer 2 is a timer with pre-scalar, a post-scalar, and a period register. And my friend continues, her.
Matrix keypad. Matrix keypad consists of mainly tactile switches, in which tactile switch consists of metal plate and the terminals. When we press on the tactile switch, it acts as input signal for the system and gives the output based on the specified particular input. For matrix keypad, the main uses of this matrix keypad are due to we are selecting for this matrix tactile switches due to its flexibility, space efficiency, cost effectiveness, and reduced pin usage. Now, my friend Manikanta will continue the presentation.
LCD display. LCDs are full form is liquid crystal display. These modules are used in microcontroller projects and devices. It is used because of low power consumption, compact size, and ability to display alphanumerical characters and graphics. There are two types of communication modes in these LCDs. There are 8-bit mode and 4-bit mode. In this project, we use 8-bit mode communication. My friend continues.
Project simulation. Whereas PiximLab is an open source and real-time emulator developed boards with integrated PiximLab, and PiximLab, it supports some PiximLab microcontrollers. Example, PIC16F877A. It has, whereas we use MPLAB XID for programming. And my friend Haran will continue.
Let us get into our presentation. In our project, mainly we are using the PiximLab simulating tool for the simulation of our micro oven project. Firstly, for project to start the project, we have to load the hex file to the microcontroller. By reloading last the hex file, the power on screen will be looks like this: power on microwave oven. After powering on, the menu screen will be displayed on the LCD display. Like there are mainly four modes and the one optional mode like start mode, micro mode. Let us discuss about the micro mode. For selecting the micro mode, we have to click on the switch 1. After switching clicking on switch 1, we have get into the microwave mode. In this mode, we heat the entire food item which we wanted to heat, like curries, those kind of food items we have to heat entire. So that the reason we are using microwave mode, we have to set the time up to how much time we need. I'm clicking the seconds, selecting the seconds. For clearing, we use hashtag symbol. For selecting this, we use hashtag symbol. Now it is running out. The time is reducing. To pause it, we can click on pause by selecting the file. To resume it again, we can switch on 4, or to increase the timing also we can click on 4. To stop this process, we use 6. In microwave mode, it uses electromagnetic waves to cook or heat food. Microwave causes water molecules in the food to vibrate, generating heat and thus cook the food quickly. This mode is suitable for heating leftovers, deforesting frozen foods, and cooking certain types of foods that do not require browning or crispiness. Now, my friend Kulayappa will continue the presentation. Before that, let me finish this. For pausing purpose, resuming purpose, we click on the switch 4. After time is up, we get the alert message as like a buzzer. Now my friend Kulayappa will continue the grill mode.
The second mode is grill mode, whereas we start the grill mode by clicking second switch. And here we see the timer, and we want to set the timer. We will select 10 seconds, and hash is used to enter. Here we will see that timer will start, and we use four fifth switch to pause, whereas grill mode is similar to similar microwave mode. And my frame will continue the third mode convention.
Convection. Convection mode is used in this by clicking on the switch 3. In this, we need to declare the temperature first. We'll declare it into 30 degrees. There is a predefined time for 18 seconds for preheating. Normally, convection mode heats up the entire system using the fan and exhaust system to circulate hot air around the food. The fan helps to ease circulation of the food heat evenly, and which is a most important thing in cooking. Here the buzzer says us to set the time. We'll set it to 10 seconds. We can pause our system by clicking on the switch file. In general, convection mode is used for baking cookies, cakes, and roasting meat. It is significantly reducing the time for cooking and often yielding better results when comparing to conventional baking. So, these convection mode is used for baking purposes. It gives better result than normal mode. We'll resume the process. Here the buzzer indicates the process is over. My friend Haran will continue.
As we have already discussed as in the micro mode for heating purpose for the entire food item. Similarly, like grill mode, we use to heat the only top of the layer for the crispiness of the food item, like we egg puffs, those kind of things for heating the only top of the layer. We use the grill purpose. There is another option like start mode for simply heating any kind of food item for up to 30 seconds or like 1 minute. For general purpose, we use this start mode. For selecting, we click on the fourth switch. For again to it runs up to the 30 seconds. It will enable time. So if you wanted to increase, we can click on the again 4 means it will increase the time. For starting and stop, pause, stop, all the same as up before process. The implementation slides, like already we have seen this procedure. Power on screen looks like this: microwave mode and cooking mode display, grill mode and convention mode. Embedded systems are like the hidden magic in every object. Thank you for giving this opportunity.
Thank you all.
Thank you for